This is AQA Level 2 Certificate in Further Mathematics, Specimen 2020 Series, Gcse. Okay, let's start. Question 1a, y to the power of 6 times y over y to the m is y to the 4. Circle the value of m. So now, in this case, 6 plus 1 minus m equals 4. So m is 7 minus 4. So m is 3. Work out the value of n. In this case, we can see that if we do n plus 5 is 5, n is simply 0. Work out the value of p. Okay, so 5p is equal to 12. So p is equal to 12 over 5. Or we can write it as 2.4. Moving on. Question 2. Solve the cube root of 7x minus 13 is equal to 2. Cube both sides. So 7x minus 13 equal to 8. So 7x is equal to 21. So x is equal to 3. Question 3. Now work out the values of a and b. So if I expand out on the left-hand side, I get 6ax minus 3a plus 4ax plus 20 is identical to 60x plus b. Now collecting the x terms, I have x into brackets 6a plus 4a, and the constant terms are 20 minus 3a. And this is identical to 60x plus b. Now, comparing the x terms, or rather the coefficient of the x terms, we have that 10a is equal to 60. So a is equal to 6. Now to find b, compare the constant terms. So we have 20 minus 3a is equal to b. So what we do is do 20 minus 18 is b. So b is 2. So right answer a 6 and b is 2. Question 4, AB is a straight line with the ratio AB to BC is 5:2. Work out the coordinates of C. Okay, so this is pretty straightforward. Okay, so the x coordinate is 5 plus 2/5 of 5 minus 3. Yeah, 5 minus 3. So x is equal to 2/5. 5 minus 3 plus 5. So x is equal to 2/5 of 5 minus 3. 5 minus 3 is equal to 2. And 2/5 of 2 is 4/5, which is 0.8. So x is 5.8. And our y is given by doing 5.5 minus 2/5 of 7 minus 5.5. This is a more difficult one to do straightforward, but 7 minus 5.5 is 1.5. And minus 2/5 of 1.5 is equal to 0.4 times, sorry, minus 0.4 times 1.5, which is minus 0.6. So this is 5.5 minus 0.6, which is 4.9. So C has coordinates 5.8 and 4.9. And this is because to get to C, we know that this is 5 parts and this is 2 parts. So we're adding 5, we're subtracting 2/5 from the distance between A and B. Now question 5, why is 2x to the 10 minus 3 over x squared? Work out dy by dx. This is the same as 2x to the 10 minus 3x to the minus 2. And we know that for any polynomial, the derivative is given by nx to the n minus 1. So this is 20 times x to the 10 minus 1 plus 6x to the negative 3. So this is equal to 20x to the 9 plus 6 over x cubed. Question 6, simplify fully. 15x squared minus 5xy squared over 12x minus 4y. So we can factorize the numerator. You can see 5 is a common factor and so is xy. Now to get to 15x squared y from 5xy multiplied by 3x, and we'll have a minus y, and on the denominator we'll factorize it to get 4 times x minus y, sorry, 3x minus y. So these cancels out, so we just have 5xy over 4 as a final answer to question 6. And write that down again, 5xy over 4. Moving on, question 7. ABCD is a rhombus with side length 8 centimeters. Angle ABC is 60 degrees. Work out the area of the rhombus. Give your answer in the form A root B. Now, we can do this by using the formula for an area of a rhombus. So we can actually do it in one way. Actually, let's do it a different way. Let us use that. Let me just think about which method I want to use to do this question for you. So we are given, let me just half this. Okay. Now, yeah, so I'm calling this 8. So I'm going to do a half times 8 times 8 times sine 60, which is equal to 32 sine 60. And we know that sine 60 is root 3 over 2. So that's equal to 16 root 3. But that's 2 triangles, so we're multiplying it by 2. So 2 times 16 root 3. So the area is 32 root 3 centimeters squared. And that's how we do question 7. Question 8. The curve y equals 2x cubed minus 3x squared minus 12x plus 6 has a maximum point at L minus 113, has a minimum point at M 2 minus 14, and intersects the y-axis at N. The curve crosses the x-axis at three distinct points. On the axis below, sketch the curve, label the points L, M, and N. Okay. So our graph should be very clear. So point N is 0, 6. And we're going to just see what point minus 113 would be. Probably somewhere around here. This is point L. 2 minus 14. 2 would be somewhere around here, and minus 14 is negative on the y-axis, so it'll be somewhere around here. So 2 minus 14 would be here, and we're calling this point M. And our N is 0, 6. So it'll be somewhere around here. So this is N. Now, this is a positive cubic graph, and we know that cubic graphs usually look something like this. Or if they pass this, and negative looks like this. So if we got 2x cubed minus 3x squared minus 12x plus x, it will look something like this. Let me just think about how I'm going to do this. 2x cubed minus 3x squared minus 12x plus 6. How would that look? It should look something like this, maybe. Trying to think. It's going to go up over here. To this point over here. Oh God. No, maybe if I do it this way. And then it will come down at another point on the x-axis. Yeah, it should look something like that. Question 9. ABC and D are opposites on a circle. Angle BCA is x, angle ACD is 2x, angle CAD is 3x, and angle CAB is 4x. Prove that AC is the diameter. AC is the diameter. So how are we going to prove this? Well, we could say that. Okay. Actually, let me do it this way. We know that our angles have to add up to 180. So we have an x, a 2x, and a 4x, and a 3x. So what that is 10x. So we know that 10x is 180 degrees. So x is 18 degrees. Okay. And so angle BA, or maybe if I do angle, okay, no. I want to prove that this is 90 degrees. So I'm going to say that angle ABC is 90 degrees. So I'm going to say angle ABC is 90 degrees. And since angle ABC is 90 degrees, we can say therefore that AC is the diameter. This may not be very clear, so I'm sorry, this is unclear. But this is how you prove the AC is the diameter. Question 10. F of x is given by 9x over 2 to the power of minus 1. G of x is the square root of 1 minus px cubed. Given that f of 1/3 is g of 1/3, work out the value of p. So what's f of 1/3? F of 1/3 is 9 times 1/3 over 2 to the power of minus 1. And we're saying that's equal to g of 1/3. So we're saying that's equal to the square root of 1 minus 1/3 cubed times p. Now, 9 times a third is 3 over 2. So 3 over 2 to the power of minus 1 is equal to the square root of 1 minus 1 over 27p. So this means that 2/3 is equal to 26 over 27p, and the square root of that. So if I square both sides, I get 4/9 is equal to 26 over 27p. So p is equal to 4/9 divided by 26 over 27, which is equal to 4/9 times 27 over 26. And as you can see, this cancels out, becomes 1, this becomes 3. And we know that 4 times 3 is 12, and 12 over 26. Or maybe I've done this wrong. I have no clue. I think I've done this wrong. Let me undo this bit. So I'm saying that our so I'm saying that 3 over 2 to the power of minus 1 is equal to this value. So we have 1 over 1 minus 1 over 1/3 cubed p. So I'm actually just going to square this side now. One minus p times 1/3 cubed. Now this, as I showed before, is 2/3. 2/3 squared is 4/9. 4/9 we're saying is equal to 1 minus 1 over 27p. I'm pretty sure this isn't going to give me a correct answer. However, I'm willing to give it a go. Or maybe it will give me the correct answer, I'm not sure. So this means that 1 over 27p is equal to 5/9. So p is equal to 5 over 9 divided by 1 over 27, which is 5/9 times 27. This becomes a 1, this cancels, becomes 3. So 5 times 3. So P is equal to 15. Next question. A circle center C touches the y-axis at 0.02. The line y equals k intersects the circle at points 1k and 5k. Work out the equation of the circle. Okay, so this is triangle. So we know that our x-coordinate of C is given by 5 plus 1 over 2, which is equal to 3. So our radius is equal to 3. So this is 0.3 something. Now to work out what our y-coordinate is, we can see from the graph it's 2. Okay. So we can say that it is x minus 3 squared plus y minus 2 squared is equal to 3 squared, so it's equal to 9. Okay. Question 12. AB is 4 centimeters, AC is 7, and cosine of x is minus 2 over 7. Work out the length of BC. Now this is simply using the cosine rule. So BC squared is given by 4 squared plus 7 squared minus 2 times 4 times 7 times the cosine of x, which is negative 2/7. So BC squared is equal to 16 plus 49 minus, but we know this minus will become a plus, so it will be, we know that minus 2 times minus 2/7 is 4/7, and 4/7 times a 7 is 4. And we multiply that by our 4, so we get a 16 over here. We get a plus 16. So this is equal to 81. So it's the square root of 81. So it's 9. Question 13. Rearrange to make W the subject. So we have TW cubed minus 2t is equal to 3w cubed plus a. I'm just going to move all the w's to one side, so tw cubed minus 3w cubed is equal to 2t plus a. Now w cubed times t minus 3 is equal to 2t plus a, which means that w cubed is 2t plus a over t minus 3, which means that w is equal to the cube root of 2t plus a over t minus 3. Question 14. Rationalize and simplify. Straight away, I'm going to multiply the top and bottom by the rational conjugate of root 3 plus 1, which is root 3 minus 1. So I have root 3 minus 7 times root 3 minus 1 over root 3 plus 1 multiplied by root 3 minus 1. Now the denominator is a case of the difference of two squares. So you can see that it will be root 3 squared, which is 3, and minus 1 squared. So a denominator will become 2. So it'll be something over 2. Now we have root 3 multiplied by root 3, so we have 3. Now we have a minus root 3 minus 7 root 3. So negative 10 root 3. And we are doing minus 7 multiplied by minus 1, which is a 7. So this is equal to a 10 plus 10 root 3 over 2, which is equal to 5 plus 5 root 3. Question 15. Point A lies on the curve y equals x squared plus 5x plus 8. The x coordinate of A is minus 4. Show that the equation of the normal to the curve at A is 3y equals x plus 16. The x coordinate of A is minus 4. So A is the point minus 4y. So you can work out what y is. So negative 4 squared is 16. And 16 plus 5 times negative 4 is 16 minus 20, which is minus 4. And minus 4 plus 8 is a 4. So A is point minus 4, 4. Show that the equation of the normal to the curve at A is 3y equals x plus 16. So what I'm going to do first is dy by dx. dy by dx in this case is equal to 2x plus 5. And now at the point minus 4, 4, it's equal to 2 times minus 4 plus 5, which is equal to a negative 3. Now the equation for a tangent has the gradient of minus 1 over the gradient of the tangent. So the gradient of the normal has to be equal to minus 1 over minus 3, which is 1/3. And we also know that it passes through the point minus 4, 4. So we know that it is equal to 4 equals to 1/3 times minus 4 plus c. So 4 equals minus 4/3 plus c. So c equals to 4/3 plus 4, right? So this is 4/3 plus 4. So c is going to be equal to whatever this is. So 4/3 is 1.3 recurring. So it's 5.3 recurring. So it's 16 over 3. Now rewriting this, we still have y is equal to 1/3 x plus 16 over 3. Multiplying by 3, we have 3y is equal to x plus 16. And that's how we do question 15a. The normal A also intersects the curve at point B. Work out the x coordinate of B. Okay, so all we have to do now is say that we're going to substitute either 3y equals x plus 16 into the polynomial or the polynomial into the line. And I think in this case it's best to just substitute in x squared plus 5x plus 8 into 3y equals x plus 8 plus 16. So by doing that, by saying that 3 times x squared plus 5x plus 8 is equal to x plus 16. Okay, so you can do this. So 3x squared plus 15x plus 24 is equal to x plus 16. So now we can bring everything to one side. So now we'll have 3x squared plus 14x plus 8 is equal to 0. Now we can factorize this, so we need to figure out what numbers we can actually have, which will give us the coefficient of 3, the x term of 14, and the free term of 8. Okay. So we already know that it passes to the point -4. So we know that x plus 4 is a factor. So we can say that x plus 4 is a factor clearly. So now from this, we can say that's 3x. And we need to have plus 2 over here. We don't want this term. So we're just going to say x is equal to -2/3. Moving on. Question 16. The coefficient of x to the 4 term in the expansion of 2x plus a to the 6 is equal to 60. Work out the possible values of a. Now to do this, we need to use the binomial expansion. So I'm actually going to bother with this whole thing, and I'm going to say that 15 times our 16 a squared is going to be equal to 60, which means that 240 a squared is equal to 60. So a squared is equal to a quarter. So a squared is a quarter. So a is equal to plus or minus a half. Now, I think I might have actually done question 14 wrong, so I'm actually going to go back to it. Where is it? Yeah. Maybe not, I'm not sure. But moving on, carrying on. And we did this because we used the binomial rule. So we had 15 times 2x to the 4 a squared. That's how you work this out. Question 17, solve the simultaneous equations. Great. Okay, this is gonna maybe take a while, maybe not. So I'm trying to look to see if we can actually reduce any of them. Maybe I'll come back to this one. Question 18, solve x to the -2/3 is 12 1/4. So 1 over x to the power of 2/3 is equal to our 49 over 4. So from here we can say that x to the power of 2/3 is equal to 4 over 49 Now, to simplify this, we can multiply this and say x to the 2/3 to the power of 3/2 is equal to 4/4/9 to the power of 3/2. So this is the square root of 4/49 cubed. So this is 2/7 cubed, which is equal to 8/343. Question 19. F of x equals 2x cubed minus 12x squared plus 25x minus 11. Use differentiation to show that f of x is an increasing function for all values of x. So I'm actually going to first work out the derivative. F dash of x is 6x squared minus 24x plus 25. Now to show that it's increasing, I can actually say that I will do x 6 times. Now I will have in the brackets an x squared minus 4x, close my brackets, and have it plus 25. So this is equal to 6 times x minus 2 squared plus 25. So this is always greater than 0 because anything to the race squared is always greater than 0. Show that 2 times the cosine squared of theta is the same as 2 minus 2 sine squared theta. This is a very simple argument, so we're going to say that 2 times 1 minus sine squared theta, which is equal to, like we said, 2 minus 2 sine squared of theta, 20b, and solve this equation. So this is just from previous 2 minus 2 sine of theta plus 3 sine of theta. And we're saying it's equal to 3. So sine theta is equal to 1. Hold on. This is 2. I made a mistake here. I meant minus 2 sine squared theta. So we have that 2 sine squared theta minus 3 sine theta plus 1 is equal to 0. So we will have let's see, 2 sine theta minus a half and sine theta minus a half minus 1, sorry. So the sine theta is half or 1. And when is sine theta a half? Well, we know sine theta is a half when theta is equal to exactly 30 degrees. Okay, so 30 degrees. We can say that it's also going to be when it's exactly equal to 90 degrees is sine theta. Sorry, sine of 90 is 1 and also 150 degrees. It's the end. Going back, just checking everything. I still have to do question 17. Okay, trying to see which one make it easier to eliminate. So I'm going to do it this way. So I'm going to say that 2 times 2a plus b minus c minus 4a minus 3b minus 2c is equal to 2 times 8 minus 9. Sorry, minus 9. So this means that 4a cancels out with this 4a. This 2b will stay. And we'll have a minus 3b. So we'll have a 5c, sorry, 5b. And the negative 2c over here cancels out and becomes positive. So when you subtract them, it'll be 0. So 5b is equal to 25. So I can say that b is equal to 5. Now we can also say that 2a plus 5 minus c is equal to 8. So we can also say that 6a, oh, come on, 6a plus 15 plus c is equal to 0, which means when you add them, we get that 8a plus 20 is equal to 8. So 8a minus 12. So a is equal to minus 3/2. And from here, we can just substitute back in. So we know that 2 times minus 3/2. So 2 times minus 3/2 plus 5 minus c is equal to 8. Okay. So minus 3 plus 5 is 2. So 2 minus c is equal to 8. So c is equal to minus 6. And that is what we do. So we have a is equal to negative 1.5 minus 3/2. B is 5. And C is minus 6. So question 16 is fine. Question 15, it's all good. I think I made a mistake. I still think I made a mistake in question 14. I don't think this is right. Yeah, this is definitely not right. Root 3 multiplied by root 3 is 3. Root 3. Okay, yeah, I see what I've done wrong. This is meant to be a, this is wrong, this is wrong. This should also not be positive. This should be 3 minus 8√3 plus 7/2, which is equal to 10 minus 8√3/2 which is equal to 5 minus 4 root 3. And that's the answer to question 14. Not anything else. All fine over here. Yeah. All good. And yeah, that is the end of the first paper. Pretty simple.